Hi, today we are going to see about the electric supply system. So what is this electric supply system? So it is generally a components of power system. So it is going to give supply from generating station to the consumer premises. So it has majorly three components. One is generation, another one is transmission, and third one is distribution. So the electric supply system has three major components. One is generation, and second part is transmission, and third one is distribution. So generally what do you mean this electric supply system? So it's nothing but the conveyance of electric power from the generating station to the consumer premises. So generally speaking, power stations are built which is at favorable places, which is quite away from the city. So where we need different power stations, and the raw materials which is required like coal and large amount of water, which is all available in away from the city. So we are going for generation of power which is at the favorable places, which is quite away from the city. So we have the generating station, which is generation at the generation voltage at the kV level of 11 kV, and through the step up transformer it is stepped up, which is transformer over a long distance, and we have a step up transformer which is at 11 kV bar 132 kV, and which is transferred to the next level 132 kV bar 33 kV. In between the first level we will be calling it as primary transmission, and second level it is called primary secondary transmission. So which is transferred over a long distance through the transmission line conductors, and which is received at the next substation. So which is called receiving station. And further it is transferred over a long distance. So which is primary distribution. So which is 33 bar 11 kV. So at this point where we have a large number of consumers, big consumers that will be supplied, and second level substation, which is our secondary distribution. So at last it's given to the consumers. So this electric supply system has four different levels. One is the primary transmission, then second one is the secondary transmission, then third one primary distribution, then secondary distribution. We have two substations in between. One is the receiving end station, another one is the distribution substation. So we have generally a major advantage of why we are going for high voltage transmission. So stepping up the voltage to 11 kV at the starting point from the generating station, and it is stepped up to 132 kV, and it is transmitted over a long distance. At receiving side, it is again stepped down to 33 kV, and which is distributed to the big consumers, where industries, institutions like we have a power supply at the rate of 11 kV, and normally we will be calling it as big consumer. And at last, at the receiving station, we will have the secondary distribution, and the transmission level kV is 11 kV bar 400 volts, where we can supply many small consumers, many single phase and three phase supply consumers we can supply. So this transmission can be done either in two cases. Transmission is there over HT conductors, and distributing the power to the consumers at two different modes. One is the overhead transmission and another one is the underground transmission. Both the cases we have many advantages and disadvantages. Normally we will be calling it as overhead system, and next one is the underground system. So normally this overhead system, which is harmless, which is hazardous to the human beings and other birds, which is open to atmosphere. So there is a problem where natural disaster may affect the transmission line, and there is a formation of lightning. There is a chance for lightning hit on the overhead transmission line. So there is major advantage. It's not safer to the humans. And whereas if you're going for underground system, it is highly safer. So it will improve the viewability of the system, and also it has major cost. So the installation cost for underground system, it will be very, very high, but advantages is better while comparing with the overhead system. While going for the distribution side, from the distribution system, it will be connected to the feeders, and from the feeder, it will be given to number of small consumers. What do you call it as? Service main. This is called service main, and this part from the distribution station to the distributor is called feeder, and this part is called distributor. So now we will see what are all the main advantages. As I already mentioned, for transmitting purpose, we will be going for high voltage AC transmission. So there is three major advantages why we are going for high voltage transmission. Advantages of high voltage transmission. So this is the overview of single line diagram of electric supply system. So generally we are going for high voltage transmission. So what is the major advantage behind high voltage transmission, and what is the reason behind? So the first thing is reducing the volume of conductor material required. It reduces the volume of conductor material required. So first we will see the proof. So we know the parameters considered. P is the power transmitted, in watts. V is the voltage in volts. Next one is cos pi, which is the power factor of load. And L is the length of the conductor. R is the resistance in ohms. Rho is the resistivity. And A is the area of cross section. So while substituting the values, so first thing is the load current, so which is represented as term I. I is equal to P divided by root 3 into V cos pi. So, which is derived from power formula P is equal to VI cos pi. So, next one is the resistance. R is equal to rho L by A. Rho is the resistivity, L is the length of the conductor, A is the area of cross section. Then what is the total power loss? W is equal to 3 into I square R. So, we know the value of I, substitute here. So, 3 into P by root 3 V cos pi whole square into R. If you simplify, you will get P squared rho L divided by V squared cos square theta into A. So, this is my total power loss, which is represented by W. Next is the total volume. Total volume is given by 3 times area into length. So, we know the value of area. From this, you can find what is the value of A. A can be calculated as P squared rho L divided by W into V squared cos square theta. So, into, so total volume is given by 3 times rho L, rho square, P squared rho L divided by W into V squared cos square theta. So, this is the total volume required. So, from this equation, we are just concluding that the total volume is inversely proportional to square of the voltage. Since your power, resistivity and length of the conductor is all constant, so only the variable parameter is voltage. So, it is inversely proportional to the total volume required. So, from this we can say that the volume requirement is less if you are going with higher voltage. V is higher, then volume will be less. So, it is the first advantage. The second one, increased transmission efficiency. Second one, increased transmission efficiency. So, we are going to prove how we are going to improve while going with higher voltage, we are increasing the efficiency. So, general formula we know input power is equal to output power plus losses. Input power is equal to output power plus losses. So, we already derived the expression for losses. So, it is equal to output power is represented by the letter P. Losses can be represented from the previous equation as P squared rho L divided by V square cos square theta into A. So, we know the current density term called J, it is called as current density, which is represented by the term J, which is equal to current per area. So, it is given by I by A. So, from this if you go for area, A is equal to I by J. So, substitute in this above equation. Now, input power is equal to P plus A can be replaced as I by J. So, P square rho L divided by V square cos square theta into J by I. Now, we know the value of current from the formula P is equal to VI cos phi, I is equal to P divided by V into cos phi. Now, substitute here in place of I, your equation revised as P equal to P plus P squared rho L divided by V square cos square theta into J into, in place of I, it is in the denominator. So, you can substitute as into root 3 V cos phi divided by P. So, now just simplify, you have P over here. If you simplify this equation, it will be called as P into 1 plus root 3 J into rho L divided by V cos theta. So, if you simplify this, transmission efficiency equal to output power by input power. Now, we have just derived expression for input power, substitute over here, is equal to P divided by P into 1 plus root 3 J rho L divided by V into cos theta. It will be revised as V cos theta. So, from this we can prove that, so transmission efficiency was over here, it is given by 1 minus root 3 into J rho L divided by V cos theta, since it is in the denominator in the negative part. So, if you increase the voltage, your efficiency will be more. So, second advantage, increased transmission efficiency we have proved. And third one is decreased percentage voltage drop. Third advantage, decreased voltages drop. So, anywhere there will be a voltage drop, depends on the losses. So, we are just proving that line drop is minimum. Line drop is given by I into R. It is given by I into R is given by rho L by A. It can be taken as I into rho L into J by I. Yes. So, from this, if you cancel I, it will be rho L J. From this expression, it is clearly shown that there will be a decreased voltage drop. So, the thing is, three major advantage. So, one is volume of conductor material required. The second advantage, increased transmission efficiency. And third one, decreased voltage drop. So while going for the supply system, so as we know the conveyance of electric power from the generating station to the consumer premises. So there will be a large network required between the generating station and the distribution network. That is where transmission system, transmission network. So there is a two-way transmission. So one is three-wire, three-phase, three-wire system or three-phase, four-wire system. So both can be with overhead system and underground system. So thank you. We'll see you in the next class.